Hello everyone. Welcome to this math PSAT practice. This is hosted by STEM 2 Girls. Just a quick notice to everyone, please do not record or screenshot this meeting. The recording will be available soon through the website and will be available through YouTube right afterwards. So please don't share the meeting link with anyone else. This is just going to be a casual PSAT practice session, and your video will not be seen in the recording. So we also ask that you do not unmute during any time. If you have any questions, and please feel free to ask, just put it in the chat through Zoom right now or through the YouTube live stream. So I'll quickly go over who STEM 2 Girls is. We're a student-led nonprofit that empowers girls and women to pursue STEM careers by providing STEM-related workshops, resources, and opportunities. Despite being a relatively new initiative, we're planning on having speaker events, academic preparation, things such as this one, including in the future for the ACT, and engagement opportunities for younger children. So if you're interested at all about joining or helping out, feel free to email us. We're stem2girls@gmail.com. We have a website where there's an interest form for all the Bayport kids. You can email me, Kararine, or Jovita D'Souza, and we'd be really glad if anybody could help or get involved. So our Instagram, if you want any updates, is STEM2Girls @STEM2Girls. And we also have a website where we'll be adding on and doing more things with at stem2girls.org. Okay, I'll be introducing myself. Hello, everyone. My name is Kararine. I'm a senior at Bayport High School. I am a National Merit semifinalist through the score I got on the PSAT last year. I'm also a perfect scorer on the ACT. I've taken the SAT and the Mathematics Level 2 SAT subject test, which they don't do anymore, but on both exams, I got the perfect score or maximum possible score on both exams for the math portions. So pretty much what I'll be doing is I'll first just talk about the structure of the math section, so the time, the number of questions, and then next it would be the big bulk of it. So I'm going to just review on some subject refreshers and content you should know. And then I tried to pick a little bit more difficult problems that you might see on the exam tomorrow about the content or the concept. This again, I know the PSAT is tomorrow, so I don't expect, if you don't learn it or you don't know it, it's completely fine. This is just meant to refresh your memory, and hopefully you can learn something or feel more prepared for tomorrow. And then at the end, I'll just be briefly discussing what to do about time management if you run out of time or if you're struggling to answer a problem. So with the format, there's two sections. There's a smaller, shorter, no calculator section. So there'll be 13 multiple choice. There'll be 4 grid-in questions, meaning you don't have a choice to choose from. You have to write down your answer, like 8, and then fill in the number corresponding to it. So you would bubble in 8 in the grid-in. You can also grid in fractions or decimals. So there's a lot of answers you can grid in. And those 17 questions will be done in 25 minutes. For the calculator section, which is a bit longer, it's 27 multiple choice and then 4 grid-ins, and it's 45 minutes. One thing, and I don't think most people know this, is that usually the multiple choice, as you proceed on with it, it's going to get a little bit more difficult. So you should anticipate spending some more time towards the end. And with those multiple choice questions, they might be just incorporate more steps or more concepts than the very beginning. So what does the math section test? Well, first I'll say is that you don't need to know advanced math topics like calculus. I don't think it even tests algebra 2. It's more about testing your grasp of fundamental concepts from algebra and geometry and how you can use them to solve the problems they give you. So they have 4 main areas, and the first 2 are the majority of the questions. So with the heart of algebra, it focuses on solving variables, systems of linear equations, setting up linear equations, knowing how to graph them, or how to manipulate an equation like multiplying or subtracting. For the problem solving and data analysis, it involves questions with rates and ratios and percentages. You might also need to interpret data. So there might be a graph or a chart or a data table, and you might have to calculate the probability using the numbers in there, or you might have to know the mean or the median, or you just have to summarize and interpret what the graph or data shows. So this is the vast majority of these questions come from these 2 topics. The third section is called Passport to Advanced Math. This area focuses on kind of how you would incorporate math into other fields like economics or science. So this is where quadratic equations and polynomials are into. There might be more word problems asking you to interpret an equation or interpret a graph and how that might apply in a situation in the real world. And then the last topic, and this is what I'll be going over very briefly. Okay, somebody asked a question, is scratch paper allowed on the math portion of the PSAT? From my knowledge, it's very iffy. You will have for sure enough space. I don't have that much space because I screenshotted the problems, but usually there's a big white space around each problem for you to scratch on. But you can ask your proctor, and if you really show that you write really big, they might let you. So I'd ask your proctor beforehand, since you wouldn't know the size of it, but usually with each problem, there's only 2 or 3 problems per page. They offer you a lot of room, so I wouldn't worry about that as much as someone who writes pretty big. So for the last topic is just additional topics in math. This is only 2 questions total in the exam, one in the non-calculator and one in the calculator. And it can be about a variety of subjects. It can be about maybe trig identities like SOHCAHTOA, I'll mention at the end, radians. If you know the unit circle, that might be helpful. Maybe some type of geometry theorem or solving for angles. But again, this is very little of the exam. And I'll be going over some of the popular topics for this. So first, I'll be going over the heart of algebra problems or topics. So let's just start off with the basic solving for a single variable. So when you're given an equation, let's say 3x plus 3 equals 60, you would first have to subtract the numbers in order to leave the x on one side. So the 3x minus 3 equals 40, you would have to, I forgot the numbers, you'd have to add 3. Okay. Okay, also I put this sticker over the question, so just I could explain how to do things first. So after you would add or subtract numbers, you can divide or multiply to leave the x or the variable on its own. So one such question that I'll leave probably a minute to answer is this one right here. The function f is defined by fx equals 3x minus 3 for what value of x is f of x equals 48. And I'll mute and I'll leave around 40 seconds to answer this. Okay, I'll just be going over how you would work it. So the f of x is given as 48, and they give us the equation 3x minus 3. So we can set 48 to equal to the equation 3x minus 3. So to isolate this variable, we would add the number, which is 3 in this case. And so one side would equal 51, and we're left with 3x. To isolate, we would divide by 3. And 51 divided by 3 would be 17. So that would be B. Okay, next would be solving for one variable using a system of equations. So there's usually two ways to solve it when you have two equations and each have two variables. The first is substituting. So let's say you have the 3x equals 4y and x equals 5y. So what we can do is use this x to substitute the 5y into. So we could do the 3, 5y equals 4y plus 3, and then solve for y. That's how you can use substitution. For elimination, we can eliminate one of the variables by manipulating the equation. So let's multiply this equation by -3, which will equal -3x equals -12. And leave the top as the same. If you add both of these equations, we're left with 0 right here, because adding 3x minus 3x is 0. So that would leave -12 plus 4y plus 3, and you could solve for y like that. And that's how you would use elimination. And then once you've solved that one variable, you can plug in that answer into one of the equations to solve for the other. So for this other example problem I have right here, you can choose one of the two methods to solve for the answer. So I'll explain this. The two equations they gave above, it's very easy to eliminate a variable because they gave us a positive y in one and a negative y in the other. So we can very easily just eliminate these two equations by adding them together, and that would result in 3x. We no longer have a y, so then 5 plus -2 would equal 3. So 3. And then x, to isolate it, we need to divide the number by 3, the equation by 3. So x would equal 1. But the question, which you have to read really closely, is asking for the specific value of x plus 2y. So we not only have to find y, we have to plug these into this little equation. So let's find y. To find y, we just plug in x equals 1 into one of the equations. So I'll choose the top one. So 2x plus y equals 5. Plug in 1 for x. So we have 2 plus y equals 5. We subtract 2 from both sides, so y would equal 3. So the value of x plus 2y, since we have both variables now, would be 1 plus 2 times 3, which would be 1 plus 6, and that's 7. So the answer would be D. For a lot of problems with the PSAT, it can really trick people up if they solve for a single variable, but they're asking for a specific value that uses the variable. So make sure you always read the question really closely to see what they're specifically asking for. Because if you notice here, they had the value of y. And if we solve for y first, let's say, it would have been really easy to skim over what they asked and just choose C right away. So always make sure to read the question. So this next part is exponents, and I hope this is a refresher. The ones that are truly needed for the PSAT, I think, are the product rule, the quotient rule, the power rule, I'd say, and then this negative exponent rule, where 1 over a of m equals a of negative m, a to the negative m. So we can use these exponent rules to manipulate formulas or to solve for a specific variable. So let me use this practice question. I think this one's a little tougher, so I'll give around a minute. Okay, I'll read over the question and then go over it. In the expression above, b is a non-zero constant. The expression is equivalent to x squared for x is greater than 0. What is the value of 2b over 3? So it is saying that this expression up here is equal to x squared. And to find this value of 2b over 3, we need to find what b is. So we have to manipulate this formula in order to solve for b. So if we notice the negative exponent rule, when something is 1 over a to the m, it's also a to the negative m, and that's the same case for this first term. We can rewrite that first term as x to the negative b over 3. And that makes it very easy to solve for b now. So x to the negative b over 3 is equal to x over 2. And since the bases are the same, they're x, we can just set b, negative b over 3 equal to 2. Multiply both sides by 3 to solve for b. So b would equal negative 6. But if you notice, they're asking again for what this value of 2b over 3 is. They're not asking for b. So be sure not to choose A answer A just because it has -6. So 2b over 3 equals 2 -6 over 3. So 2 times -6 is 12 over 3, and that is equal to -4. So B would be our answer. So I have this problem here about simplifying expressions. So in the case of a question that has this, this is all about combining like terms. So x cubes are subtracted and minused by also x cubes, so you can change the constants on those. In this special case, specifically with this problem, there's a negative, so you have to be sure to distribute the negative sign. So I'm just gonna rewrite the whole problem so that we can make it so we are able to combine the terms. So first they give us 4x cubed minus 5x squared plus 3. So then we would distribute the negative. So it'd be minus 6x3 minus 2x squared, and then plus x, because again, we're distributing the negative to this whole expression because it's subtracting. So now it's time to combine like terms. So we see a 4x cubed here. We see a -6x cubed here. We see a -5x squared here, a 2x squared here, and then finally we have 3 as a number, and then we have x as a number. So 4x cubed minus 6x cubed, let's start with that, would equal -2x cubed, minus 5x squared minus 2x squared then would be -7x squared. Then it would be plus x plus 3. But if you notice, they already had that in the answers, so you wouldn't need to spend time on it. And that would result in B. So in this case, it's just important to organize your terms and make sure you're adding the coefficients to the right terms in the like terms. So next is a problem about inequalities. So inequalities are similar to kind of linear equations, but instead of it being equal to, there's a less than or a greater than, or a less than and equal to, or a greater than equal to in an equation. So I'm going to explain this first problem here, where we're given actually a set of linear equations. So it says if y equals x, which of the following represents all values of x that satisfy the system of inequalities above? So we're looking for x, and we don't have to solve for y because they give us y. And so we can just plug that in right here. So that would be 2x plus 6 is greater than or equal to 10. And then x is less than or equal to 5. So we have to isolate for this second equation the x to see what also the limitations are. So if we subtract both sides by 6, that would equal 4. 2x is greater than or equal to 4. Divide both sides by 2, x would be greater than or equal to 2. So now we know that x has to be greater than or equal to 2, and x has to be less than or equal to 5. So we have to find a number line that corresponds to that. And that would be A. Or it could be written as this. One thing to not forget if you have an inequality, that if you are, we are a little bit lucky with this problem, but if you are multiplying or dividing a negative number, you have to switch the signs. So let's just say hypothetically that this right here was -2x is greater than or equal to 4. When we would have to divide it by -2 to isolate x, and then we would have to change the sign to less than or equal to -2. So that's a really easy thing to forget. And sometimes the answer choices are not kind enough, so they will have that answer anticipating that people can do that. Also, what this problem doesn't include is if there was no less than, there would be a hollow circle like that. So a solid circle is when there's an equals to involved, but if it's a hollow circle, it will be just less than or greater than in a number line. So I have another question about inequalities because they can show up in different ways. And this time it's about setting up a formula or interpreting a situation and setting up an inequality. So Carl's expenses for not making a product are $4.50 per piece. He will make a profit of between $1 and $2.50 per piece, depending on the final sale price. If Carl sells 50 pieces, which of the following inequalities represents the total profit he will make? So one really important thing with word problems, because they can seem wordy and they're unnecessarily so. So the question is asking about what is representing the profit. And so all we need to know is about the profit, and they give it to us right here. He makes a profit between $1 and $2.50. And we know that for this specific problem, he sells 50 pieces. So this very first sentence about expenses, we just don't need to care about, and it doesn't apply to the problem. So we know that for the lesser end of the profit, he'll get $1, and on the higher end, he'll get $2.50 per piece. So the profit is, say, somewhere between here. So now it's asking about 50 pieces. So we would multiply both sides by 50 because we already have the profit per piece. So it'd just be 50, and then it would be 2.5 times 50. It would be 125. And that would leave D. So I'm going to move on to the next section of the types of problems they give, and this is the problem solving and data analysis. So this section is relating to rates, proportions, percentages, slopes, then we look at data and probability. From my memory, I took the PSAT last year, and I also took it as a sophomore just to take it for practice. And from both exams, I remember there was a big focus on rates and slopes. So just having a strong grasp on how rates can relate to a problem or how slopes are involved with graphs will be a really important part of doing well in the exam. So I first have a question relating to percentages. The cost of a certain shirt is $20 before a 5% sales tax is added. What is the total cost, including sales tax, to purchase the shirt? So we know that before the tax, it's $20. And then after, the 5% is included. So we have the before taxes right here, the $20, and then we would have the sales tax of the $25. So we have 0.05, which is what you would multiply for 5%, and then times it by 20. And I think this problem uses a calculator, so let me use my calculator, though it could be solved by hand. Okay, so we have 20 plus, and in my calculator, 5% of 20 or 0.05 times 20 is 1. So this would be a $21 sale. So we needed to know that to find out the 5% of the $20. And you would multiply 0.05 by 20, and then you would add that to the initial cost before the tax, which was 20. Okay, second problem is, I believe, a proportion one. For proportion problems, you might have to cross multiply to find out the ratios between things. I think that is the case with this example. Miguel had made multiple batches of a juice recipe that requires 4 cups of water and 2 cups of fruit juice concentrate. If Miguel followed the recipe for each batch and used a total cups of fruit juice concentrate, 6 cups of fruit concentrate, how many total cups of water did he use? So the problem here gave us the ratio. There's 4, I'm just gonna put water, and 2 fruit juice in each batch. So if he followed the recipe, and we know he used 6 fruit juice concentrate or cups, we're trying to find how much water he used. So there's 2 ways you can do this. You can cross multiply like this. So you multiply the denominator of one side times the numerator of the other, and then solve for, I'll put this as variable x instead of question mark. So it would look like 2x equals 4 times 6, and 2x would equal 24, x would equal 12. I think the easier way in just this problem is that you notice that there is 2 times the cups of water than fruit juice, right? Because there's 2 fruit juice cups and then there's 4 water cups. So it's doubled. So 6 fruit cups, and then double it again would be 12 water cups. But in a case where the ratio is not as nice, it's always safe to do a cross multiplication. So I have some more problems. This one is about percentages. The number k is 36% greater than 50. If k is the product of 50 and r, what is the value of r? Okay, so there's a lot of words here. It's almost like a riddle. The number k is 36% greater than k. So k equals 1.36 times 50. Be careful not to just write 0.36 times 50. In this case, it's greater than. So it's all of 50 and then the 36% of 50. So you would have to multiply by 1.36 times 50. There's another way that is a little tricky, is if they said if they said 36% less than 50, you would not write 0.36 times 50. You would have to do whatever 1 minus 0.36. You would have to do 0.64 times 50. That would be the correct thing. This is wrong because that's only 36% of 50. To be less, you have to subtract it from the decimal, subtract it from the whole, which is 1. So just be really careful with setting up these equations when there's percentages involved. So if k, the second part they gave us is if k is the product the product of 50 and R, what is R? So this is also in the case of substitution. We can set this 1.36 times 50 right here. So 1.36 times 50 equals 50 R. We don't need any type of calculator because there's a 50 on both sides. So we divide both by 50. They're left out. So R would equal 1.36, which is C. So especially with percentages and when you're setting up things with all these words, just make sure you are doing it correctly and you're setting up the multiplication correctly. So for this second problem, this is more about ratios. On June 9th, 1973, a horse named Secretariat ran a distance of 12 furlongs in 144 seconds. What was the average speed in miles per hour that Secretariat ran for the 12 furlongs on that day? So we're going to have to do a lot of unit conversion since they gave us seconds, furlongs, and we have to change it to miles and hours. And we know that there are 60 seconds in a minute, 60 minutes in an hour, and then they also gave us the conversion of miles and furlongs. Okay, and I think this problem needs a calculator also. So we know that there were 12 furlongs in 144 seconds. We can just convert both units, the furlongs and seconds, to their intended answer. So for the 12 furlongs, we know that 1 mile. Okay, I'm going to set this up in a better way. I think the better way to set it up is we just write their conversion first. So 1 mile is 8 furlongs. And we are given 12 furlongs. So we have to know how many miles these 12 furlongs are. So we will cross multiply, and that also cancels out the units once you cross multiply and set them equal to each other. So we know that 8x equals 1 times 12. So x equals 12 over 8. That's 3 over 2 miles. We will have to use probably a calculator once to get the speed. So to convert the seconds, we know that there are 60 seconds in 1 minute. And we know that there are 60 minutes in 1 hour. So there will be 2 conversions. This one will be the second one for the time. So we'd have to solve for how many minutes it is first. So we know it's 144 seconds that day. And then we would again cross multiply to find the number of minutes. So it'd be 144 times, let me set y minutes. So it would be 60y. So y would equal 144 divided by 60. So it would be 144 divided by 60 minutes. And then we would have to convert it to hours. So we have this conversion I put right here. I'm going to move it just to be able to see it. So again, we're going to set it up. So 144 divided by 60 minutes. And we're left to solve, let's say, Z hours. So there is, when you cross multiply 144 divided by 60 times 60 Z. So the number of hours would be 144 60 times 60 hours. So we have these numbers. Right here we have the time, and then we have right here the miles. So we can just enter that in our calculator. 3 halves miles, and then divide that whole thing by 144, 3,600 hours. And the answer I get is 37.5. So the average time you spend on a problem is 1.5 minutes, and that was a lot longer than 1.5 minutes. So this was one of the questions that was towards the end. I remember taking this from, but usually you can also do this in your head, because 12 furlongs, and they just already tell us what 1 mile is. You can easily see that it's 12 divided by 8. And I went through each conversion of the seconds and the minutes, but it's also very easy to just divide by 60 twice, because there's 60 seconds in 1 minute and then 60 minutes in 1 hour. You would just write 144 divided by 60 times 60. But I want to show that the way you should do it, and it's safe, is through cross multiplication. Okay, this is one more problem I have relating to rates. The velocity of a space shuttle increases at an approximately constant rate during the first 5 minutes after launch. Of the following graphs, which best represents the velocity of the shuttle during the first 5 minutes after launch? So it's telling us here that there's an approximately constant rate during the first 5 minutes. And we just have to do the graph that corresponds to that. So the words constant rate should signal in your head, and that's a code for a linear relationship. So that means a constant increase or a decrease. There's other relationships. There's linear, which is the line you see that's constant, and there's a slope and it's consistent. There's also quadratic equations, which is like x squared plus 4. So there's a U-shaped curve. And then there's exponential relationships. So maybe y equals 2 to the x. So usually for very rapid growing things like exponential growth and decay, which has very rapid growth or decay, or the y on a graph, the y becomes a lot higher, a lot quicker compared to a constant slope of a linear relationship. So for a lot of rapid growth or decay, that's associated with exponential relationships, while slower growing constant ones are the linear ones. But anyway, the constant rate means linear relationships, and there's only one that has the constant rate that increases. It constantly increases, I should have said. It's not just constant, and that's D. So there is a type of slope, and it's consistently increasing. Here, it's increasing a lot faster and then slowing down. For here, it's it looks more like a quadratic equation, but it's increasing a little slower and then rapidly increasing. And here it just doesn't increase at all. Okay, so next we'll be talking about slope. So you should be familiar with the slope-intercept equation, y equals mx plus b. So m is the slope. So this is the change in y over the change in x. Or you can use 2 points. So the second y point times the first y point, or subtract the first y point over the second x point minus the first x point. So it would look like this. If you have 2 points on the same line and you want to find the slope. So in this question here I have, what is the slope of the line in the xy plane defined by the equation y equals x over 3 plus 6? Well, they gave us the exact slope-intercept equation. So it's right here. But obviously the slope isn't x over 3, it's 1/3, because x over 3 can also be written as x times 1 over 3. So it's another way of just saying y equals 1/3 times x plus 6, which imitates the slope-intercept form. So the answer is 1/3. Slope can also appear in a lot of word problems where they might ask you what's the slope in this word problem, or what is the rate, or what does it mean in this problem. So here m equals 165 times w. So what is that? The equation above can be used to determine the total amount of money, m in dollars, that Stephanie will be paid for w weeks at her new job. Which of the following is the best interpretation of the number 165 in the equation? The number of hours that Stephanie will work w weeks after starting the job, the rate in dollars per hour at which Stephanie will be paid, the amount of dollars that Stephanie will be paid each week, the total amount of money in dollars that Stephanie will be paid for w weeks of work. So we know it can't be A, because 165 is not about the number of hours that she will work. The 165 multiplied with the W, the weeks of work, will result in the dollars she'll get paid. So it's not the total amount of money either. That's what the M is. That's what the Y is. So in B and C, B mentions a rate, the rate in dollars per hour, in which Stephanie will be paid, and the C says the amount of money in dollars. So we can also see right there the difference in the unit. Because this is just a constant, it's the number 165, this is just about the money she's being paid per week. So it's not the rate itself. It's about the amount of money that she'll be paid each week. So if you go on a graph, the x-axis would be the weeks, and the y would be the amount she's paid. So 165, 1. So after 1 week, she'll be paid like this. And then after the second week, she'll be paid 165 more. So it's just the amount of money she gets each week. And it's impacting just the y, which was the dollars. This is another question using slope. I think it's a little trickier if people forget what perpendicular slopes are. So the graph of the linear function of f is shown in the xy plane above. The graph of the function g, which is not shown, is a line that is perpendicular to y equals f of x, or the line in the graph, and passes through 8, 0. Which of the following defines g? Okay, so I'm going to highlight the word perpendicular because that is the most important thing. So first, we're not even given the equation of f of x. We have to find that out using the graph. So we can use the slope-intercept y equals mx plus b. So let's find the y-intercept first, or b. So that's where the line will meet the y-axis. This is the y-axis. We can see that right here at this point, it meets the y-axis, the line. And that is at y equals -1. So b will equal -1. We also have this point right here at 3, 1, 2, 3, 1, 2, 3. We have a point at 3, 3. So just using this y-intercept and this 3, 3 point that they showed us, we can figure out the slope. So using the y2 minus y1 over x2 minus x1, it'll be 3 minus 1, and then it'll be 3 minus 0. So it'll be 4/3. So the slope is 4/3. For it to be a perpendicular line to this slope right here, to this line that has the slope 4/3, the perpendicular line would have to be a slope that is negative and the reciprocal, or the opposite in the reciprocal. So opposite, when it's 4 -3, the opposite is -4/3. I'm going to say perpendicular slope. So the m. And then you would have to do the reciprocal. So it'd be -3/4. So the new slope, I'm going to start writing my work a little bit to the left. So the slope of the perpendicular, we already know now is -3/4. So we can start setting up the y equals mx plus b equation. So we already know what -3/4 is the slope times x, but now we need to find b, the y-intercept. But how will we find that? Well, if we look at the question again, they give us a point it passes through. So we can plug in the point in the x and y, and that'll leave the b. So plug in 8, 0. It'll be 0 equals -3/4 times 8 plus b. So 0 equals -6, because you can cross multiply this, or cross both and multiply, plus b. To isolate b, we would add 6 to both sides. And so our equation we finally have now would be y equals -3/4 x plus 6. Now let's see if there's the answer here. It would be D. I realized as I was doing this problem that it was unnecessary to even find the slope-intercept, but I could point it out since they had the point on the y-axis. Though if you are solving for the problem as quickly as possible, you don't need to find this whole equation. You just need to find the m and then use it to find the equation of the perpendicular line. Okay, the third section, the passport to advanced math. So again, this is about understanding quadratics and polynomial equations. So I'm going to be going over really quickly the parabolas. So it's the U-shaped curve, and the vertex form, and the vertex is kind of the bottom point. You can see in this example, it's right here, the bottom point of the curve, or if it's facing like a U this way, it's the top point of the curve. That's the vertex, that point. So parabolas, they can be written using this form where there's a constant a, and then x minus h squared plus k, and hk is the vertex. It's a good thing to remember for this form that in the parentheses, it's x minus h squared. So the h would be the opposite of what you see. It's not -1 would be the x point of the vertex, because the k, you just add the k, but the h, it's subtracting from the x, yeah. So in this example right here, we're given x minus y squared plus 2. And so this bottom point is 1, 2, the vertex, and the axis of symmetry is the x point of the vertex. So in this case, it's x equals 1. It's called an axis of symmetry since your graph should look like it could mirror each other on both sides of this axis. It should look symmetric. So let's do some problems. So f of x equals x squared plus 4. The function f is defined as shown. Which of the following graphs in the xy plane could be the graph of y equals f of x? So it's just asking, what is the graph of this expression? So one of the easiest ways we can see this is just plug in x equals 0. And when x equals 0, 0 squared plus 4, the y coordinate should be 4. And the only option that has that where the 0, 4 coordinate exists is D. Also, if you remember that x squared is a parent function, and it looks like this, and the vertex will be at the x coordinate of 0, the y, or the k, is whatever is added on. So the vertex would be at 0, 4. Okay, the next problem is right here. The graphs of the functions f, g, and h are shown in the xy plane above. If f of x equals ax squared minus 3, g of x equals bx squared minus 3, and h of x equals cx squared minus 3, where a, b, and c are constants, which of the following is true? So this problem is testing the constants. And so the constants are affecting the vertical stretch or the compression of the quadratic equation. So I'm going to just write the constants for h, it's c, for g, it's the constant b, and then for f, it's the constant a. We can see that h, which has the constant c, is kind of the skinniest. It's the most elongated. The y is moving quickly. It's increasing a lot faster than the other two. For the b, or the g function, it's a little wider. And for f, which has the constant a, it's the most compressed. So when there's vertical compression, stretching, like it is in h and c, it's very skinny and looks like it's being stretched. That means the constant is a higher number. So c would probably be the greatest number because it's moving, the y's are bigger. Even despite that they are all having the same vertex, it's going up a lot quicker, the y coordinates. Next would be g, because it's in the middle of c and a in terms of moving quickly with the y's and x's. So C would be greater than B, and that would be greater than A. So that would just be answer A. So I have an extra question. The graph in the xy plane of the equation y equals ax minus h squared plus k, which is the vertex formula also, where a, h, and k are positive constants, is a parabola that contains the point 2, 4. The graph of y equals a x minus h squared plus 2k must contain which of the following points? Okay. Well, if we write the two equations, we'll notice that the only difference is between the constant with the k right here. So we know that it's the k, which is the y coordinate, will be affected because it's doubled in the second equation. And because it is a positive constant and it's doubled, it's just going to be 4 more. So it would be 2 and then 4 plus k. Let me make sure. Okay, yeah. You can also test it by just plugging in some type of numbers. If I'm unsure like I am right now, you could do y equals ax minus h plus 3, and then y equals ax h plus 6. And then, yes, this would be affected, the y coordinate. So the answer would be D. So next is more about a data set and finding the means of the center. So the mean is the average. It's the sum of all the numbers, and then it's divided by the number of numbers or the items. So if there's 5 values, add those values up and then divide by 5. The median is when you list the set of numbers from smallest to greatest. It's the middle term. If there's an even number of numbers, you take the middle of the 2 numbers. If it's an even set of numbers. For the mode, it's just whatever the most frequent number is. So if it's a set of numbers like 1, 2, 2, 3, 2 would be the mode because it shows up twice, and it's the greatest number. It shows up. So I have this problem here. The frequency table above shows the gross number of trips made by 40 heads of household to a grocery store in a given week. Which statement is an accurate analysis of these data? So we can see in all the answers, there's something about the median and there's something about the mean. So we have to, if not figure out, we have to estimate. So for the median, because they already list from least to greatest, we just have to find where around the 20th household is, because that's towards the middle. So it would be 4 here, would be 6 here, then 7, since we're going to the middle between the least and greatest, and we're counting the frequency. So that would be 13. This would be 18. Once we go here, and then here is 17. So this would be 21 between 2 and 3. So we know the median would be somewhere in 2. So we would find, if we know that there are 40 heads of households, so we try to find the 20 and 21st, and both of them are under the frequency of 2. So I'll write median equals 2. So now we got to find the mean. And the mean, we would have to use a calculator, and we would have to add up the frequencies and numbers of trips or multiply them. We would add up all these numbers then, and then divide it by 40, since it's 40 heads of households. So what it'll look like is going to write it. So number of trips, that's 1. That's for 4 people. Number of trips, 2. That's for 17. 3 times 5. 4 times 7. And so on. And then you would divide this all by 40, because the total number, the frequency is 40 because it's a response from 40 people. But we have to find the values, add up all these values of the number of trips to find the average. So let me enter that into my calculator. And I got 3. I got the top value, I got 120, then it's divided by 4. So we know that the mean is equal to 3. So we know that the 3 is greater than 2, so the mean is greater than median. So the median number is 1 more than the mean, nope. The median number is equal to the mean, nope. C, the median number to a grocery store is 1 less than the mean. Yes, that's what we got. The median number of weekly trips to a grocery store is about 4 less than the mean. Nope. So we got C. Okay. So sometimes in the math passages, they'll give you some type of situation or word problem. They'll give a couple graphs or a line on a graph or a scatter plot like this, and they'll have a certain number of questions associated with that little passage. So both 7 and 8 are related to this graph of body mass and length. So it says right here, the scatter plot above shows the body mass M in kilograms and the length D, round to the nearest centimeter, of 20 bottlenose dolphins. The equation of the line of best fit not shown for this data is 0.43 plus 176. The point of best fit is kind of what around the estimate of a linear equation will be for these points. So based on the line of best fit, which of the following statements is true? As the body mass of a dolphin increases, the length of the dolphin decreases. So body mass of a dolphin increases, the length of the dolphin increases. So body mass of a dolphin increases, the length is constant, and there's no correlation. Well, this line of best fit we're referring to, or we can just look at the graph, it shows that as the body mass is becoming greater, so does the length. And this positive slope right here, the 0.43, also says that as the mass increases, so will the length. So as something increases, the other increases too. And the answer that matches that best is B. Next, what is the median length in centimeters of the 7 longest dolphins? So we have to find the 7 longest dolphins. So that means we're using the y-axis and looking at the highest y coordinates, not the x coordinates here. So I'm just going to circle 7 of the longest. So this is the highest or the longest. 1, 2, 3, 4, 5, 6, 7. Okay, and then to find the medium, we will find the medium of this data set. And because it's on a graph, it's already there from greatest to smallest of our little set. So this is the greatest. This is the smallest. This is one of the smallest, one of the greatest. Again, one of the smallest, one of the greatest. And that leaves this point right here. I'm going to erase it a little bit. And we can see right here that corresponds to 280, the length. So the answer would be C. There's no calculations in this case. It would just be identifying and then marking the 7 biggest lengths and then counting 4 from there, the 4th term. So I'm going to go over the additional topics. I don't have as many problems here, but I will have some of the topics that are usually tested if there are tested. So just remember the Pythagorean theorem. This is when you want to solve one side of a right triangle. So the hypotenuse c squared is equal to b squared, one of the sides or legs, plus a squared, the other side or leg. If you have trig knowledge, sometimes SOHCAHTOA can be helpful along with the unit circle. So SOHCAHTOA is helping you find the angle in a right equation. So sine, so opposite over hypotenuse. So in this case, it would be the opposite here for the hypotenuse. So if this was 3 and 5, it would be 3 over 5, and this would be 4 in a triangle, right triangle. A very popular triangle is a 3, 4, 5 triangle. For cosine, it's the adjacent, so what's next to the angle, the leg, over the hypotenuse. In this case, it'd be 4 over 5. And tan is the opposite over the adjacent, which would be 3 over 4. And this would help you find, again, the angle related to the right triangle. There might be a question asking about volume. I think it's good to remember the area and the circumference of a square. That's right here. So the area of a circle is pi r squared. The circumference, or the little perimeter, is 2 pi r. Knowing triangles, rectangles, as well as just volume formulas, length times width times height. Usually that just helps you so you don't have to go through a lot of pages to find the reference sheet. But if there is some type of volume and they don't provide you with the formula in that problem, it will be accessible on that front page of your section, and you'll find something like this. So one question that I do remember they tested a couple times is complex numbers. So that's a number where there's a real part and there's an imaginary part with an I. So it's in the form a plus b, I. So it's something like a and b are real numbers. So let's say 2 plus 3i. That's a complex number, 6 plus 7i, and so on. And so what I is the square root of -1. So you can see in this chart here that I to the first is I, or -1. Again, it's called imaginary because you can't take square roots of a negative number. You can take the square root of 1 or the square root of 4, but you can't really take the square root of a negative number. So it's imaginary, yet it's very powerful for a lot of equations. So I squared would be -1 squared equals -1. And then it would be I2 times I would be like this. So I squared times I squared equals I to the 4th is 1. Because it's -1 times -1. If there is something that is I to the 60th, which is divisible by 4, right? 60 divided by 4 is 15. If it's divisible by 4, that means that it will equal 1. So sometimes a test might ask about an exponent relating to the I. I have 2 problems relating to the complex numbers. Let me scroll down. So one of them is another way to ask about complex numbers. So it's solving what is equivalent to this fraction they give us with i's in them. And so what you do in this case, if you haven't learned it, is called multiplying both the top and the bottom by the conjugate. So if you notice in all these problems, there's some type of whole number, an integer at the bottom, but we have an I in our original equation. So to get rid of that I, we have to multiply both sides by the conjugate. And the conjugate is this, it's 8 minus 2I. And because we're manipulating the equation, we also have to multiply the top of 8 minus 2I, because we're multiplying it technically. This is 1. But the reason why we do the conjugate is because it will eliminate the i's and we'll have a real number. So if we use the FOIL method between these two expressions, we have 64 minus 16i plus 16i minus 4i squared. So as you can see, the i's cross out. So the conjugate is changing the I, the 2I, and to the negative or to the opposite, because then we can cross out the i's in the middle. So this means the denominator would be 64 minus 4i squared. Remember, I is square root of -1, so I squared would equal -1. So it's 64 minus 4, -1, and that's 68. So we still have to solve the top though. So again, we will FOIL this. So this time there won't be any crossing out the i's because it's not a conjugate of the numerator. So it'll be 24 minus 6i, the outside. The inside will be 40i. And then the outside, or the last, will be 10i squared. So 24, the like terms, plus 10 to the -1. That means 24 minus 46i minus 10 equals 14 minus 46i. So now we have, I'm going to write it towards the bottom, 14 minus 46i over 68. If you notice the question, the answers don't have any 68s under them, so we have to simplify this. And as you can notice, each of the numbers here can be divisible by 2. So it can be 7 minus 23i divided by 34 if we take out the 2's from the top and the bottom. And that, you can also rewrite it and separate the numerator, 7 over 34 minus 23i over 34. But this is C. So usually through complex numbers, they're either going to ask something like this, where you need to multiply the conjugate, Or they might ask something that takes a bit less time, and it's this question right here, where it's just um, solving the expression by combining like terms. So negative 3i to the 6, let's solve this part first, and then we'll do this next. If we remember that I to the 4th is equal to 1, and this is all I 4th times I to the 2nd is equal to, I'm going to rewrite this, is equal to I to the 6th. So it means I to the 3rd equals negative 1, or equals 1. I to the 4th equals 1. And I to the squared, I squared, is equal to negative 1. So we have negative 3 times negative 1 equals 3. So this first part we know is 3. Next, we have to distribute the negative sign to this expression because it's in parentheses. So we have minus 4 minus 2i, and we're left again with plus 2i. Okay, so right here, minus 2i plus 2i, just cross them out. And we're left with 3 minus 4, which equals negative 1. D. So an example of a question like this, it combines your knowledge of complex numbers, how to simplify an expression, and how to distribute the negative. So this kind of builds upon some of the problems we did earlier. So that kind of reaches the end of my practice problems. I'm just going to say quickly some things I'd suggest. For time management, on average, you will have around 1.5 minutes per problem. But as I said earlier, you're going to spend a bit less time towards the beginning, and you're going to spend a bit more time towards the end of the multiple choice anyway. The grid-in might be difficult, it might not be, or depends on the problem. So if you are stuck on a problem or you just have no idea how to solve it or where to start, and you know that for a fact, do not waste 3 minutes or 4 minutes or 5 minutes and become stuck on that problem when you can just move on. And you can mark in your answer sheet maybe like a little star in the answer sheet, and just if you have enough time to move back on it, because every single problem is still worth the same. They're all 1 point. So if you're stuck and you waste time on this one problem for 5 minutes, you're taking away time for some other questions that you might have answered if you had slightly more time. So if you are truly stuck on a problem, mark it in your answer sheet and just come back to it. And that leads me to the answer every question. Sometimes it's hard to finish the exam, or you might not finish all the problems. So what you do is you pick your favorite letter. My favorite letter was B. So if I either truly had no idea what I was going to answer, or I just didn't have enough time to finish, I would choose a letter and I'd fill them all with the same letter. So if I didn't answer 3 questions during the last 5 seconds of the exam, I just fill in the B bubble. I don't suggest choosing a different letter for every question, because just statistically, if you choose one question, stick with it, you'll have a 25% chance. And that lowers if you just choose A and then B and then C. That is one of the bigger things with the questions. As I said earlier on, if you have to double check the question and make sure you're answering the right thing. You might have to solve for B in a question, but they're asking about 2B plus 3. And the thing is, usually College Board is not nice enough to just have that one answer. If you solve for B, they will probably have B on there, and then once you mark that and forget about it, you got it wrong for something that you could have easily gotten right. So making sure you're focused on what you are answering and making sure it's the right thing. I know this because I remember last year when I had enough time to look back and make sure I filled in each bubble, I realized I got the very first question wrong. It was a very simple 2x plus 3 equals 6. It was something like that. And I realized I just wrote the wrong number down and I got a different number, and they somehow had it on the answer sheet. So having that kind of accuracy is so important. For some of these multi-level step problems, the arithmetics and the calculations, if they're slightly off, they can derail you and you might have to spend more time. So in that case, just make sure you are doing what they ask of you and trying to do it in the quickest way possible. For some of the calculator questions, because they allow a calculator, you might feel uncomfortable to just do things by hand. But some questions you can spend much less time on by doing by hand because you realize it's a very simple calculation, or it's something you can just easily do on paper and you didn't need to spend all that time typing in your calculator. Obviously, you might probably do have to use a calculator on some problems, but that's not always the case. My other last thing is that on the PSAT, it is a bit easier than the ACT and SAT. Just there's a little bit more time per problem. The questions aren't as advanced yet. And so I say this for the grid-in because there's no choice of questions, that usually the grid-in questions are a very simple number. So usually they're whole numbers. It could be 1, it could be 8. And of course, it could be double or triple digit numbers. Usually they're kind of very easy to put in and solve fractions also. So like 1/3, you would write 1/3, and then you would fill in the bubbles of 1/3 or write 0.3333. So what I'm trying to say through all of this though is that it's okay if you don't do perfect, obviously. You just try your best. This is a really great way to experience and build up kind of stamina that you may need for the SAT and the ACT. The PSAT is kind of the first time you have a chance at doing an exam that requires multiple hours. It's a broad overview of reading genres and editing skills and writing, and finally the math. But I want to say that you shouldn't overthink the PSAT because you do have a solid grasp of the concepts that you learned in class, and they're just trying to test it a different way. Because it is a standardized test, they don't have an extreme problem that they haven't tested or made sure is still able to be done by a high school student. So that's kind of the end of my advice. If anyone has any additional questions or questions about it, I'm very willing to answer. And I'll stay on a little bit, but for everyone doing it tomorrow, good luck. Please do not forget to bring a calculator. I did that my first time, and it was chaos trying to have my mom go back home and get my calculator in time. So don't forget to bring a calculator, make sure it's charged, and have a good sleep. So that's it. Thank you for joining me, and good luck tomorrow.